Number 5, integrate using partial fractions. Partial fractions is a way to take a single fraction into sum of simpler fractions. And if you have a fraction that has x minus 1 in the denominator and another one that has x plus 2 in the denominator, and if you think about adding these two, well, because you would need the common denominator, you will end up with this common denominator x minus 1 times x plus 2. So this actually can be done, and since the numerator should be one less order, at most one less order than the denominator, we can put an a here, and one less order than the denominator would be b. Now, if the numerator had first order or higher, then you can always do the division. You can do the long division and put that aside. So you're going to get, you can always make that kind of a fraction into where the numerator is less order than the denominator. Okay, now we have to figure out what a and b is, and basically what you want to do is you want to put the two fractions into one by multiplying by x plus 2 top and bottom and x minus 1 top and bottom. Since now you have the common denominator x minus 1 x plus 2, you would have a times x plus 2 plus b times x minus 1. Let's proceed further. This would be ax plus bx plus 2a minus b over x minus 1 x plus 2. So that's going to give you a plus b x plus 2a minus b over x minus 1 x plus 2. And since this has to equal to this x plus 3, we can deduce that this a plus b should correspond to 1 times x. So a plus b should be 1. And 2a minus b should equal to 3. 2a minus b equals to 3. And then the way you solve this would be just add like that. It would be 3a equals to 4. So a is 4/3. And putting that back in here, I have 4/3 plus b equal to 1, which gives you that b is equal to negative 1/3. Now there's a quicker way to get the same answer. As a comparison, if you have, in the beginning it's the same thing, but if you multiply this to the other side, then you end up with x plus 3 equal to a over x minus 1 times x minus 1 x plus 2 plus b over x plus 2 times x minus 1 times x plus 2. These cancel and these cancel, and you end up with x plus 3 equal to a x plus 2 plus b x minus 1, which is essentially the same thing as this thing that we got. Okay, so we have this equal to that. And this process can be done almost immediately without having to go through all this. If you train your mind for better mental math, it should be very easy to start from here and come here. Alright, now what you do is, since this should be true for all values of x, you can just set x equals to negative 2. And the reason you want to set x equals to negative 2 is because you want to set this equal to 0. So if x is negative 2, this is going to go away. Negative 2 plus 3 will be 1. And then here I have b, negative 2 minus 1, so that's negative 3b, which gives you b equals to negative 1/3. And if you plug in x equals to 1, this time this is going to go away. 1 minus 1 is 0. So you end up with 4 on the left side and 3a on the right side. That gives you a equals to 4/3. And that's much faster than doing all this. Okay? Let me try to erase this. Okay, so now that we have the values of a and b, what we get is that integral of x plus 3 over x minus 1 x plus 2, that's same as a over x minus 1, and a is 4/3, so it's 4/3 over x minus 1 plus negative 1/3 over x plus 2. And this one here, if you look at this and this, these are algebraically equivalent. So this single fraction is the same as the sum of these two different fractions. But the nice thing about this second one is that it's a lot easier to integrate because you can use the property of integrals, that you can split the addition and you can pull the coefficient in front. And then when you integrate the 1 over x minus 1, oh, by the way, this comes in very handy. If you integrate f prime over f dx, that's same as integral. That's same as log of f, log of the denominator plus c. This indeed happens a lot when you integrate these. So if you have 1 over x minus 1, you can see that differentiating x minus 1 gives you the top. In that case, it's of this form. You get ln of the denominator. Same thing here. If you differentiate x plus 2, you get 1. So it's the ln of the denominator. So that's the answer. Let's try the second one. 4x cubed plus 12x plus 4 over x squared plus 1, x plus 1 squared. Now, one thing that you have to be careful is that this time you could set it up like this, and since this is second order, you put ax plus b, and for this one is cx plus d. But if you put it like this, then it's hard to integrate later. So instead of doing it this way, what the textbook tells you to do is to put it like c times x plus 1 plus d over x plus 1 squared. So instead of x, you put x plus 1, which in turn means it's c x plus 1 over x plus 1 squared plus d over x plus 1 squared. And since these can't cancel, you end up with c over x plus 1 plus d over x plus 1 squared. Okay. To summarize, what it means is that you need this to equal to x squared plus 1. You can't factor. In that case, you just write down the quadratic without doing any factoring. But then since you want something that's one less order than the denominators, you put ax plus b. Now, for the case when you have something to some power like that one, then you start from the very basic one and you go up till it's ordered. So if this was 3, then you would do c over x plus 1, d over x plus 1 squared, plus e over x plus 1 cubed. So that's how you solve these partial fractions. Okay, let's try to use the same method as before. If I multiply this to the right side, I'm going to get 4x cubed plus 12x plus 4 equal to ax plus b times x plus 1 squared plus c times x plus 1, x squared plus 1, plus d times x squared plus 1. Okay, so that's what we get. X equal to negative 1 is a great number to plug in because that's going to get rid of these. And negative 1 squared is 1, 1 plus 1 is 2. So you end up with 2d only on the right side. On the left side, there is negative 1 cubed, which is negative 1. So negative 4, negative 12 plus 4. So that gives you negative 12 equals to 2d, which gives you d equals to negative 6. And x equal to 0 at least gets rid of a. So that gives you b on the right, and also c on the right, and also d on the right, which is equal to, if you plug in 0, you get 4. And since d is negative 6, if I replace this negative 6 into d, then you're going to get 10 equals to b plus c. After moving the negative 6 to the left side, you get 10 equals to b plus c. Okay. Now, when you run out of good numbers to plug in, then you don't have much choice. You would plug in something like x equals to 1. There is a slightly better one that you can do, which is to look at the highest order term. Say, imagine that you expanded this. Then it's a times x cubed. That will be the highest order term, because ax times x squared will give you ax cubed. And then it's going to have some lower order terms. What's the highest order term here? That's c times x cubed. And then a bunch of some other terms, I don't know. And this one will have dx squared, so that's less than cubed. So you see that the only cubic term on the right side is a and c, so ax cubed plus cx cubed is what you get as the cubic term. Now if you look at the left side, the cubic term is 4x cubed, so they're going to equal each other. So that means a plus c has to be 4. Okay, we have 10 equals to b plus c, a plus c equals to 4. And since our unknown is a and b and c, we need one more equation. So I guess we don't have much choice but to plug in x equal to 1, in which case 4 plus 12 plus 4 would be 20 on the left side. On the right side, this is 4, a plus b times 4, so it's 4a plus 4b. And then if I plug in 1, that will be 4c. And then I will get 2d, which is equal to negative 12. Okay, now let's see. Everything's divisible by 4, so let's divide by 4. You get 5 equals to a plus b plus c minus 3. So that means a plus b plus c is 8. Now, didn't we get that a plus c is 4? So since a plus c is 4, what would b be? b plus 4 is 8. b must be 4. If b is 4, I get c as 6. And if c is 6, then when you plug in here, I get a as negative 2. So all this work led us to the following thing. Let me try to make a new page. Alright, so we have the following result, which says 4x cubed plus 12x plus 4 over x squared plus 1, x plus 1 squared, is negative 2x, a is negative 2, plus b, b was 4, over x squared plus 1, plus, and then c was equal to 6, and then d was negative 6 over x plus 1 squared. So this is what we get. Let me just check. C is 6, b is 4, d is negative 6, a is negative 2. Okay, so that's what we have. Now, since we have the integral of the left side, that must mean that we have to integrate this. A major mistake that people make is that when you do this partial fraction question, you forget that you have to integrate. So that, and people just stop right here. Okay, so you have negative 2x over x squared plus 1 And then you have 4 over x squared plus 1. I'm splitting all the fractions. And then integral of 6 over x plus 1. And then negative integral of 6 over x plus 1 squared dx. Okay, now what is this? This is f prime over f type, right? Because if you differentiate x squared plus 1, you get 2x. So it must be the ln of the denominator. Now this one here, it's 4 times 1 over x squared plus 1, then, and 1 over x squared plus 1 has the antiderivative of arctan. This is again, if you pull the 6 out, this is f prime over f, again, x plus 1. If you differentiate, you get 1, so you get ln of the denominator. And this one, well, you're trying to integrate. Well, let's see what this is. If you integrate 1 over x squared dx, that's integral of x to the negative 2 dx, and you add 1 to the exponent, which is negative 1, and you put the reciprocal of negative 1 in front, so it's 1 over negative 1. So that's negative 1 over x plus c. For the same reason, if you integrate x plus 1 squared, it's going to end up with negative 1 over x plus 1 plus c. And if you want, you can make this negative as plus, and that will be the actual integral. Okay, so this is the case when you have an even number of exponents, even exponent in for trig functions. So whenever you have like sine to the 4th x dx, or integral of cosine of 8x dx. If you have questions like this, you're always going to be using these formulas. Okay, so let me show you how this one works. Since this is integral of 1 minus cosine of 2 theta over 2, according to this is now equal to this. The only difference is instead of a, we have theta. And you have d theta, which is, you can pull the 1/2 out, and then you're integrating 1 and cosine 2 theta d theta. If you integrate 1, that gives you theta. Integral of cosine is sine, but then because of the chain rule, if you differentiate sine 2 theta, it's not going to be cosine 2 theta, it will be 2 cosine 2 theta. So to get rid of that 2 when you differentiate, you should put a 1/2 in front. Now to check, how do you check your result? Well, if you take the derivative, you should get what you started with, right? So if you differentiate, that's 1/2. When you differentiate theta, that's 1. When you differentiate sine, it's cosine 2 theta, but when you bring the 2 theta out and differentiate, you get 2. And when 1/2 and 2 cancels, you get exactly what you started with. And that's why we know that this is correct. Now for the second one, same way, 0 to pi. Replace a by x over 6, so it's going to be 1 plus cosine of 2 times x over 6 over 2 dx. And 2 and 6 reduces to 3, so 1 plus 1/2 of integral 0 to pi of 1 plus cosine x over 3 dx. And then when you integrate 1, it's x. When you integrate cosine, it's sine. And again, since this is 1/3 of x, the reciprocal of 1/3 should also appear in front. So you get x plus 3 sine x over 3, and you have to plug in pi and 0, which is 1/2 x plus 3 over 2 sine x over 3. Now you still have to plug in pi and 0, so let's plug in pi. That's going to give you pi over 2 and plus 3 over 2 sine of pi over 3. And when you plug in 0, that's 0. Sine of 0 is also 0, so when you plug in 0, it's just going to give you 0. So pi over 2 plus Since sine pi over 3 is radical 3 over 2, you get 3 radical 3 radical 3 over 4. So that's the final answer. Find the derivative of the following functions defined by integral. Well, for this one you have to use the thing called the second fundamental theorem of calculus. Which says that if you have a function defined as an integral of some function t, then the derivative of that is basically what's happening is you're integrating it and then you're differentiating that one. So since integration and differentiation these are opposite operations, you're going to recover your original f. The only thing that you have to be careful is that when you do this definite integral, after you integrate this, you plug in these endpoints, right? So the result of this integration is a function of x. And since you're differentiating a function of x, it should still be a function of x. So that's the result. Now if I use this, then the simple result that we get is that f prime of x would be just x being plugged into this. This replaces the t cubed. So I get x cubed as the answer for the first one. Now you have to be very careful not to try to integrate this. See, if you're finding the derivative of the integral, don't bother doing the integral, because integrals are usually given as something that's impossible to integrate. This one, when you try to integrate, it's going to require something called elliptic integrals, and you can never integrate these. Okay, now let's go for B. Now for B, it's not so straightforward because of this sine x there. That's going to make the matters very complicated. Now one way to do this would be to set u equals to sine of x, so that when you have dg dx, meaning that you're trying to differentiate d dx of this 1 to u of square root of 1 plus ln of t dt, since now we have changed this into a function of u, you should try to change that as a function derivative by u instead of d dx. Instead of d dx, you can rewrite this as d du. And then to cancel this du with that, I put a du here, and since there was a dx there, this is what you put. This is the Leibniz form of the chain rule. You can see that these two are same because once you cancel the du and du, you end up with the same thing as before. Now, since these two match, this u and that u matches, now the fundamental theorem of calculus does work. And by the way, what's du dx? Du dx is cosine of x, so I put cosine of x to replace du dx, times, since you're differentiating u by u, again the second fundamental theorem of calculus does take effect, and u goes into this t, so you have square root of 1 plus ln of u, and since u is equal to cosine x times 1 plus, since u is equal to sine of x, I can put that as the answer. Now let me make one more remark here. See, if you had if you had trouble finding out how this was solved, let me give you a second way to solve this. So for the time being, think about the antiderivative of 1 square root of 1 plus ln of t dt. Now, usually when you're given these derivative of the integral questions, you end up with an integral whose antiderivative cannot be computed at all, regardless of how good you are with u substitution and integration by parts or any other integration methods. It's not going to come out as some regular functions. There are many integrals, seemingly easy integral questions that doesn't have an answer. So this doesn't have an answer. You can try. And since you're trying to find the derivative of this integral, somehow you can avoid having to have the concrete result at hand and still be able to find the derivative. So the trick is to do this. Just say that the entire derivative is named h of t plus c. Even if we don't know what it is, we can just name it, right? The only thing that we do know about ht is that if you differentiate ht, then it's going to recover what you integrated. So that's basically the only thing that we know about h of t. It's the fact that its derivative is square root of 1 plus ln of t. Now we have g of x equal to integral of 1 through sine of x square root of 1 plus ln of t dt. And because we're now pretending that we do know the antiderivative, which is h of t, you plug in sine of x and 1, so that gives you h of sine of x minus h of 1. And now we have to figure out what g prime of x is. G prime of x would be h prime of sine of x. Notice that sine of x is a nested function, so its derivative should be attached outside. So it would be cosine of x. And what about the derivative of h of 1? Well, since h is a function and you evaluate it at 1, this is some value. It's a constant. It doesn't have any x in it. So when you differentiate by x, this will be treated as a constant, so it's going to be 0. And because we know that square root of 1 plus ln of t is the derivative, and now we have, instead of t, I have the sine of x in there, that t would be replaced by sine of x, and what we get is square root of 1 plus ln of sine of x times cosine of x, which is exactly the same answer as this one. So I think this is slightly easier to think than that one. But since I'm presenting you two different ways, whichever you like, you can choose. Find the area enclosed by two graphs. Okay, so you have two graphs, and one's a straight line with y-intercept at 5, and the slope is 2, so it's something like this. This is some kind of parabola. I don't know. I don't even know if it touches. It's just some kind of parabola. Okay. Now, if you have a parabola and a line like that, I guess the enclosed area would be meaning something like this one. The thing is, we need to know where they meet, or else we don't know what to integrate. How do you find out where they meet? Well, you set them equal to each other, which gives you x squared minus x minus 2 equal to 0, x minus 2, x plus 1 equal to 0, so you have x equals to 2 and negative 1. So this would be negative 1 and this would be 2. Therefore, the area would be integral from negative 1 to 2 of top minus bottom. Since the line is above the parabola in the shaded area region, you should do 2x plus 5 minus x squared plus x plus 3 dx. And that is negative 1 to 2, negative x squared. 2x minus x will be just positive x, and 5 minus 3 will be plus 2. Antiderivative is 1 over 3 x cubed plus 1/2 x squared plus 2x from negative 1 to 2. 2 cubed is 8, so you have negative 8 over 3. 2 squared is 2. 2 squared is 4. 4 divided by 2 is 2. 2 times 2 is 4. So that's what you get when you plug in 2. Minus, when you plug in negative 1, that's positive 1/3, because negative 1 cubed is negative 1. Negative times negative positive. Negative 1, when you plug in, there will be positive 1/2. And when you plug in negative 1, there will be negative 2. So now, negative 8/3 minus 1/3 would be negative 9 over 3. You'll still have minus 1/2, but this is 2 plus 4, which is 6. 6 minus 2, so 6 plus 2, which is 8. Now this is negative 3. Negative 3 plus 8 is 5, so you have 5 minus 1/2, which in turn is 9 over 2. Find the area between two graphs over the interval 1 to 3. Also sketch the region. Alright, so how do we sketch y equals to negative x squared minus x plus 10? Well, I think this is negative of x squared plus x minus 10, and since, this cannot be factored, I see. Well, first of all, I know that it's an upside down parabola, and where is this point? Where's the vertex? Vertex happens when y prime is 0, so y prime equal to negative 2x minus 1. Set that equal to 0, and you get x equals to negative 1/2. So I know that x equals to negative 1/2 is the point where you have the vertex. And also, when you plug in 0, you get the y-intercept as 10. So if I say this is 10, it's going to pass through this point, and since it's the vertex, vertex is at negative 1/2, so it should be higher than 10 there. So we see that the graph must be something like this. Okay. Let me try again. Should be something like this. Okay, and then y equal to x plus 2, what's that? 2 would be something here, and then y equal to x plus 2 would be something like this. Now, over 1 to 3, so it's over 1 to 3, and, well, we need to know where they actually meet, so let's try to set them equal to each other and figure out where they actually meet. When I move everything to the left side, I get x squared plus 2x minus 8 equal to 0, and that factors as x plus 4, x minus 2 equal to 0, so x is negative 4 and 2. So they actually meet here at negative 4 and meet here at 2, so I guess this point is like 2 at 1 and 3, you get these shapes. So if I zoom that in, I will get something like a bow tie type region where this point is 2. Now what's happening is that before 2, so here's 1 and that's 3. Before 2, I see that the line is below the curve. So from when you do the area, you see that from 1 to 2, you should be doing negative x squared minus x plus 10 minus the line x plus 2. Whereas from 2 to 3, now the line is above the parabola, so this time you have to do x plus 2 minus negative x squared minus x plus 10, because you have to do top minus bottom. Alright, so what are we integrating? 1 to 2, negative x squared minus 2x plus 8 dx, plus 2 to 3, x squared plus 2x minus 8 dx. The antiderivative is negative 1/3 x cubed minus x squared plus 8x, and you're plugging in 2 and 1, plus 1/3 x cubed plus x squared minus 8x, and you're plugging in 3 and 2. when you plug in 2, that's 8, 4, 16, minus when you plug in 1, that's negative 1/3, minus 1 plus 8. And then here, it's when you plug in 3, you get 3 cubed, that's 27. 27 divided by 3 is 9. 3 squared is 9. Minus 3 times 8 is 24. Then minus, you have when you plug in 2, that's 8 over 3 plus 4 minus 16. So that's what you get, and I'll leave it to you to figure out what this actually becomes. Sketch the region enclosed by these two. Now this time, x equals to negative y squared plus 1. What's the graph of this? Well, x equal to y squared is a parabola that opens right instead of, see, y equal to x squared opens up. If you put a minus, it goes down, right? So if you have the form y equals to some quadratic function of x, it either becomes a parabola opening upwards or opening downwards. But if you have x equal to y squared, it either opens right or to the left. And if you have a minus, that's when you get the left. So knowing all this, we know that the graph of this would be opening left, and because you're adding 1, it moves 1 to the right, and you get the following graph. Now if you're not so sure of how to draw this graph without knowing all this, you can simply plug in values. So you can do x, y, but it's convenient to put values into y and then to solve for y after plugging in values for x. So we're just going to put into y negative 1 and 0 and 1. In that case, when you plug in negative 1, you get 0. When you plug in 0, you get 1. When you plug in 1, you get 0 again. So you get the 3 points, which are 0, negative 1, 1, 0, and 0, 1. So if you had these 3 points, this point, this point, this point, and then you had just a slightest idea that this type will give you a parabola opening right or left, then of course the parabola that's passing through these 3 points would be this. So it must be a parabola opening left. Okay, so knowing that, now what is the graph of x equals to negative 3? X equals to negative 3 would be here. And we're looking for the area enclosed between these two things. And we need to know when they meet, so we set them equal to each other, which gives you, if I move this here, move that here, I end up with y squared equal to 4. That gives you y equals to plus or minus 2. So here it's going to be positive 2, here it's going to be negative 2. Now, in the case when you have a function of y, then you should integrate by y, but then you should do right minus left. Since the right side is the parabola, we should be using negative y squared plus 1 as the thing that you want. And then minus, the left is x equal to negative 3, so you put negative 3 here. And y goes from negative 2 to 2, so you put negative 2 to 2. And that gives you negative y squared plus 4, integral from negative 2 to 2. Oh, this is a symmetric domain. Negative 2 and 2, that's a symmetric domain. In that case, you can just double from 0 to 2. And it's a real time saver. If you do this, you end up with 2 times negative 1/3 of y cubed plus 4y. And you have to plug in 2 and 0. So when you plug in 2, that's negative 8 over 3, that's 8. So 16 over 3 times 2, that's 32 over 3. Alright. Arc length. Okay, what's the arc length formula? Arc length formula is that you have to integrate over any domain, a to b, of square root of 1 plus f prime of x squared dx. So if you use this, you'll be able to find all the solutions. So here we have y equal to ln of cosine of x. So what's that? Y prime is 1 over cosine of x, and then because of the chain rule, you have to differentiate the inside function, which gives you negative sine of x, which gives you negative sine x over cosine x. And then since this is the derivative, that goes in here. Your interval is from 0 to pi over 4. You have square root of 1 plus negative sine x over cosine x squared dx. Negatives is going to go away when you square them, and then because this is sine squared of x over cosine squared of x, you want to put these two fractions together, so you write it as cosine squared of x over cosine squared of x. Now, it's very tempting to take the square root of each one of these. I hope you never do that, because if you do that, first of all, it's not right. A lot of people think that this is equal to a plus b. That's never true. Well, only if one of these are 0, that's true. But usually, as long as one of these are, both of these are non-zeros, then this is never true. And it will also get the graders mad. So you're going to get a really poor grade if you do something like that. Okay, so don't ever do that. You can only take the individual square roots when it's a division or a multiplication, but when you have an addition, you can't do that. Alright, so you have this, and then when you combine them, you see that cosine squared plus sine squared is 1. So you get 1 on top. You probably know that, right? Cosine squared plus sine squared is 1. Cosine squared of x plus sine squared of x is 1. Right? And in the denominator, you have cosine squared of x, square root of dx. And since now this is a division, that means you can take the square root of the top and square root of the bottom separately. And then you get 1 over cosine of x. Now, what is 1 over cosine of x called? It's called the secant of x. And when you have secant of x, it says the integral of secant of x is ln of secant of x plus tangent x. So we can use ln of secant of x plus tangent of x, and you plug in pi over 4 and 0. When you do that, it's going to give you ln of radical 2 plus tangent of pi over 4 is 1. And when you plug in 0, secant of 0 is 1 and tangent of 0 is 0, so you get minus ln of 1. But ln of 1 is 0. 0. So that's the answer. So the answer to this first one would be ln of radical 2 plus 1. Let's try the second one. Y prime would be 3 over 2 comes down, and then you subtract 1 off of that, so it's this negative 1. 3 over 2 minus 1 is 1/2. Therefore, when you do integral of y prime squared dx from 1 to 2, that's going to give me 1 to 2 of square root of 1 plus 3 over 2 x minus 1 1/2, and you have to square this, and that's going to give me square root of 1 plus 9 over 4 x minus 1 dx, which is 1 to 2 square root of 9 over 4 x, then minus that will be 4 over 4. 4 over 4 minus 9 over 4 is negative 5 over 4. Now, this is 1 over 4. 1 over 4, when you bring it outside the square root, since square root of 1/4 is 1/2, that can be brought outside as 1/2 from 1 to 2, and you get square root of 9 minus 9x minus 5. dx. Okay, so how do you integrate this? You use u substitution. U equals to 9x minus 5, so that du is 9 dx, which means dx is 1/9 of du, and therefore you get 1/2. Oh, when x is 1, u is 9 minus 5, which is 4. When x is 2, 9 times 2 is 18. 18 minus 5 is 13. Make sure you change the bounds. And then square root of u. The entire thing inside the square root is now called u. And then dx is 1/9 du. And that's equal to 1/2 integral of 4 through 13. And it's 1/9 times u to the 1/2 power. Okay, 1/2 times 1/9 is 1/18. And then the way you integrate this is you add 1 to the exponent, which is 3/2, and put the reciprocal, which is 2/3. And you have to plug in 13 and 4. Okay, so 2 and 18 cancels as 1/9, so you end up with 1/27 of 13 of 3/2 minus 1/27 of 4 of 3/2. And this is the best you can do without using a calculator. If you have a calculator, you can plug that in to get more, but this will be the exact value. Find the volume of the solid generated by revolving around the y-axis, the region enclosed by y equals to 2x, 2 radical x, and x equals to 2. All right, it's a little hard to see here, but this graph here, this is the y-axis, that's the x-axis, and then x equals to 2 is this, so this shaded region is what you have here, and you're trying to rotate this around the y-axis. Now we will just do the washer method here. The washer method says that if you do a cross-section like that, then after you rotate it, if you take the cross-section will look like a washer. So it'll be like a circle inside the circle, and you only get this much. Okay. And we use the formula that the volume is the integral of area times d something. And since these donuts have thickness in the y direction, see, if you imagine these small donuts like that as the cross section, and if you thicken it, where's the thickness direction? This thickness direction will be the y direction, right? So we have to put area dy, and this area of a washer is always, if the inside is small r, maybe I should draw it again. So if the inside is small r and the outside is big R, then area would be pi r squared minus pi small r squared, which is like pi times r squared minus r squared. So that's the formula that we use for A. And since y goes from, the minimum is 0, and where do they meet? When you set them equal to each other, you get x is equal to 2. So if you plug in 2 here, you get y equals to 2 right equal to. So this point here is 2 comma 2 right equal 2. Therefore, the minimum value of y is 0. The maximum value of y is 2 right equal 2. And then you're trying to find the integral of pi r squared minus r squared dy. Okay, now what is the capital R here? Capital R is this distance, which means it's the distance from the center until the end, and the outside distance is always 2 regardless of your level. So regardless of which cross section, at at any level, if you take the cross section, you will always see that the distance from the outside to the center of the axis, the axis of rotation, is this distance, and that's always fixed. It's 2. Right? You can see it here, right? For this question, it's always 2. Not always. This is just by chance that we got an easy question when you rotate around y, because outside is always 2. Now, what about the inside? Inside would be the distance between this center axis to the y-axis to this graph, right? This graph has the formula y equals to 2 radical x. So here's what I'm trying to do. I'm trying to say that at level y, I want the distance between these two. Well, this graph has the formula y equals to 2 radical x. And because y over 2 is radical x and x is y squared over 4, what it says is that if you're at level y, if the value of the y coordinate is y, then the x coordinate would be y squared over 4. And since this is 0 here, the difference between the two would be y squared over 4 minus 0. That would be the distance, the small r. So you get integral from 0 to 2 radical 2 of pi times 4 minus y to the 4th over 16 dy. And then when you integrate, you get 4y, and then you add 1 to the exponent, which is 5, and put the reciprocal, and therefore you get 1 over 16 times 1 over 5. And you have to plug in 2 radical 2 and 0. Now when you plug in 2 radical 2, that would be 2 times 4, that's 8 radical 2. And when you plug in here, 2 to the 5th power is 32. And radical 2 to the 5th power would be, what's radical 2 to the 5th power? That's radical 2 to the 4th power times radical 2. Radical 2, this is radical 2 squared of radical 2. Radical 2 squared is 2, 2 squared is 4, so you get 4 radical 2. And then because 2 to the 5th power gives you 32, you end up with 32 times 4, which is 128, but when you divide by 16, you end up with 8. So it'll be 8 over 5 radical 2. When you plug in 0, you're not going to get anything, and if you simplify this, 40 minus, you're going to get 32 radical 2 over pi. No, 32 radical 2 over 5. Let me rewrite this. What I'm trying to say is that it should be 32 radical 2 over 5 and then pi. Now we take the same region, and this time we rotate around y equals to negative 1. So see, y equals to negative 1 means you're rotating around here. Now if you rotate around here, then again, think about cross sections which are like washers. So you're going to have cross sections that look like washers in this direction, whose thickness this time will be in the dx direction. So your volume would be integral of pi times integral of capital R squared minus small r squared dx. And then your x value would be from 0 until 2, because that's the minimum value is 0. It starts at the origin, and the maximum value is x equals to 2. So it would be 0 to 2. Let's try to integrate this. Well, we still have to figure out capital R and small r. The easier part in this case would be the small r, because the inside circle always has this radius, which is the distance from the x-axis to this horizontal line, which is 1 below the x-axis. So this distance will always be 1. So you get 1 squared. But what about capital R? Capital R will be this y equals to negative 1 until this one here, y equals to 2 radical x. So the y, see this distance is the difference between the y values, and since the y values are these two, you have to do 2 radical x minus negative 1 squared dx. And if you do this, you get the answer. So it's going to be 0 to 2. If you square this, you're going to get 4x minus, actually this is plus 1, so it'll be 4 radical x plus 1 then minus 1. So this is what you have to integrate. And then when you integrate this, it'll be 2x squared plus, let's see, this is x to the 1/2. So when you add 1, it'll be 3 over 2. Put the reciprocal in front, 2 over 3. And then you have to plug in 2 and 0 with pi here. Maybe this is a little hard to see here. What I wrote here is that 2 radical x minus negative 1. So that's same as 2 radical x plus 1. So that's what you're putting in here. And when you expand this, you're going to get this because 1 will cancel with this one. Okay, when you plug in 2, it's going to be 8. When you plug in 2 here, it'll be 2 radical 2, 2 times 2 times 4, that'll be 16 over 3 radical 2. And that's it. When you plug in 0, you get 0, so you don't get anything when you plug in 0. So this is the answer. Find the limit. Now this is about L'Hopital's rule. So L'Hopital's rule says that if you have something that's like 0 over 0 type or infinity over infinity type, you can differentiate the top and bottom and get the limit. So here you have limit of x times e to the x, e to the x plus 1. Certainly when you send x to infinity, e to the infinity is infinity, so you definitely have infinity over infinity type. So this is infinity over infinity type. And when you apply L'Hopital's, always make sure you say that you have infinity over infinity type or 0 over 0 to justify your use. Now, because of that, L'Hopital's say you can differentiate the top and differentiate the bottom. Be careful, you're not using the quotient rule. If you use the quotient rule, you will get a totally wrong answer. Here it's a product, so we use the product rule, which is 1 times e to the x plus x times e to the x over e to the x differentiates to e to the x, 1 differentiates to 0. So we have limit x going to infinity. But then when you divide e to the x by e to the x, that's 1. When you divide x e to the x by e to the x, that's just x. And you're still sending x to infinity, and therefore this is going to give you infinity. Now sometimes you have a limit question that's not a fraction. Now in this case you have to change it to fraction because L'Hopital's rule can only be applied for fractions. So we multiply e to the x minus 1 to the top first one. We multiply this to top and bottom so that you get x times e to the x minus 1. And then for the second one, I multiply x and x, so it'll be minus x. Okay, so this is what you get if you put these two fractions into a single fraction. And once again, when you plug in infinity, this will be e to the infinity, which is infinity. And again, e to the infinity, so this will be infinity over infinity type. You have to remark that in order to use the L'Hopital's, which says if you differentiate this, it's c to the x. If you differentiate negative 1, is 0. Differentiating negative x gives you negative 1. And when you differentiate this, x differentiates to 1, so you have e to the x minus 1. When you differentiate e to the x minus 1, you get x times e to the x. Now you still have this going to infinity, so this is still infinity over infinity type. These two all go to infinity. So we apply the L'Hopital's again. When you apply the L'Hopital's again, we get e to the x as the only thing on the top, whereas on the bottom we get e to the x. That disappears, but this one, you have to use the product rule. And that basically brings it down to limit of x going to infinity of, well, you can divide top and bottom by e to the x. You can do that for a fraction, right? So you get 1 over 1 plus 1, which is 2, plus x, and that's gone. So now you have 1 over 2 plus x, where x goes to infinity, that's equal to 0. Okay, what about this one? Limit x going to 0 plus of 1 minus sine of x to the 1 over x power. We use the trick e to the ln of 1 minus sine of x 1 over x. So anything is e to the ln of that thing, because e and ln, when you cancel them, you come back to the original one. Now, when you put into this form, this exponent can be jumped over the log. That's a formula for logarithms. So you get 1 over x ln of 1 minus sine of x. Now, since e is constant, the only thing that you have to figure out is the limit of this. So let's try to get that limit. Limit of x going to infinity of 1 over x. Actually, it's 0 plus, right? So it's 0 plus of 1 over x times ln of 1 minus sine of x is limit x going to 0 plus of ln of 1 minus sine of x over x. Because if you multiply 1 over x to this only gets multiplied to the top. Now that you have this, if you plug in 0, you get ln of 1 on top, which is 0. If you plug in 0 in the bottom, you get 0. So it's a 0 over 0 type limit, which means you can use the L'Hopital. L'Hopital, if you differentiate the top, you get 1 over 1 minus sine of x. But then you have to differentiate the inside function, which gives you negative cosine of x. When you differentiate the bottom, it's equal to 1. Now let's see if you can plug in 0 plus. You can. If you plug in 0, you get negative cosine of 0, which is negative 1, and this is 1 and 1, so you end up with negative 1. Since this top goes to negative 1, your limit will be e to the negative 1, which is 1 over e. So 1 over e is the answer to C. Now let's do quickly the D. Limit of x going to 0 plus. This time I put e to the x times ln of 1 minus cosine of x. And this time, when you plug in 0, this is ln of 0, which goes to negative infinity. Ln of 0. If you look at the graph of ln, it's like this. So when you go closer and closer to 0, then you end up with negative infinity. So this goes to negative infinity. That goes to 0, which means that it actually is an indeterminate form. So what we do is we take limit of x times ln of 1 minus cosine of x as limit x going to 0 plus of ln of 1 minus cosine of x over 1 over x, because if you do it this way, then you have infinity over infinity time. It's really, the top is really negative infinity over infinity, but still in this case you can use the L'Hopital's. So if you use the L'Hopital's, you end up with sine of x over 1 minus cosine x as the derivative on the top. If you differentiate this, is negative 1 over x squared. And this actually becomes a really tough one. Let me just continue. So what is the limit of x going to 0 plus of negative 1 over x squared on the bottom, and what was it? Sine x over 1 minus cosine x. Well, if you take the reciprocal of this and multiply it to this, you end up with x squared sine of x over 1 minus cosine of x, negative limit x going to 0. And this time when you plug in 0, this is 0 over 0 type, so you have to yet again apply the L'Hopital, so which gives you negative 2x sine x, and then minus x squared cosine of x over, if you differentiate the bottom, it's positive sine of x. All right. So we're almost there. This is again 0 over 0, so we differentiate one more time, which gives you negative 2 sine x, negative 2x cosine x. And when you differentiate this, it's negative 2x cosine x, and then minus, actually plus x squared sine of x over cosine of x. And finally, when you plug in 0 now, the denominator is non-zero, so that makes 1 in the denominator. And when you plug in 0, sine of 0 is 0, so these two are gone. Oh, that's also 0. If you plug in 0 here, that's 0. So all this work just to show that it's equal to 0, and therefore this would be e to the 0th power, which is 1. Okay, let's try this one. Let's limit x going to infinity. If you have two fractions just like before, let's try to make them into a single fraction by introducing common denominators. And this one, if you FOIL, you get x cubed minus 2x squared minus x squared plus 2x. And this one, if you multiply them out, you're going to get x cubed, let's see, minus x squared minus x squared minus x, and then when you multiply negative 1, so that's just plus x plus 1. So all this divided by x plus 1, x minus 2. You still have to take limit x going to infinity. And then this will make x cubes to disappear. And these two will cancel each other also. This overall will have negative 4x squared, and then you'll have 2x plus 1 over, if you expand the denominator, it's going to be x squared plus x squared minus x minus 2. Okay, so this is what you have. This is definitely infinity over infinity type, but so you can use L'Hopitals, but actually the easier part is to just look at the dominant terms. Negative 4x squared, that has the highest order here, so that's the dominant one on the top. X squared is dominant on the bottom, so these two just fight each other when x is really big. So the ratio between them will be just negative 4. So this would be a problem where you can actually solve without having to use L'Hopitals. Now this one, since it's very simple, I just do it here. This is infinity over infinity type, so we differentiate the top, which gives you 2x over x squared, divided by, if you differentiate the bottom, it's 2x, and limit x going to infinity. And when these 2x cancel, you end up with limit x going to infinity of 1 over x squared, which gives you 0. Determine the convergence of the improper integral and find the value if it converges. Okay, so how do you integrate x times e to the x? Well, that will require integration by parts. U is x and dv is e to the x, which gives you du as 1 dx and then v as e to the x. So that's going to give you this times this, so x times e to the x minus integral of v du, so it's e to the x dx, which is x times e to the x minus e to the x integrates to e to the x, so it's e to the x plus c. Okay, you can do a check by differentiating this. So let's do a check. If you differentiate this using the product rule, it's 1 times e to the x plus x times e to the x. If you differentiate that, that's still e to the x. C differentiates to 0, so when these two cancel, you get x times e to the x, exactly what you integrated. So that's your check. So it does work out. Now let's send x to, now let's try to evaluate this 0 to infinity of x e to the x dx, which means it's x e to the x minus e to the x, and you're plugging in 0 to infinity. So when you plug in infinity, that's well, actually think of it like this. This is x minus 1 times e to the x plus c, right? So if you instead use that, that's x minus 1 e to the x infinity and 0. So when you plug in infinity, infinity minus 1 is infinity, and when you plug in infinity here, that's infinity. And when you plug in 0, you get some quantity, some finite quantity, which we don't care. Finite. The important thing is this is infinity, that's infinity, so that's still infinity minus some finite value, which is infinity. So that means A diverges. What about B? B would be almost the same thing. X e to the x dx, except that now we have x minus 1 e to the x 0 and negative infinity. So that gives you, when you plug in 0, you get negative 1. When you plug in negative infinity, that's like sending limit x to negative infinity of x minus 1 times e to the x. Well, since sending x to negative infinity is a little confusing, let's try a change of variables. So negative 1 plus limit t going to infinity, where t is negative of x. So when x goes to negative infinity, t would go to positive infinity because t is negative x. So you get negative t minus 1 e to the negative t. So any x is now replaced by negative t. Oh, I need more room. Let me put it right up here. So all the way here. So that integral would be equal to negative 1 plus limit t going to infinity of negative t minus 1 over e to the t, because negative t powered would mean that e to the t is in the denominator. This is certainly infinity over infinity. Well, it's really negative infinity over infinity. That's still fine. In that case, you can use the L'Hopital's, which says that it's limit t going to infinity of negative 1 over the derivative of e to the t is e to the t, and that's just going to 0, so negative 1 is what you get. Okay, so that tells you that the integral of this would be negative 1. It converges. Okay, so B converges, whereas this A would diverge.